All right. So let me say a few quick words about our speakers today. The first one, you see his picture up there. I'm sure everyone in this room has met or knows or at least has seen Walt now. I met him about 20 or 25 years ago. We were pedaling our butts off around Langley Air Force Base, which, if you ever want to know, is a perfect 10-kilometer loop. And that's where we met. And he's still active in cycling. I have kind of turned my bicycle in, but he's shortly going to be one of our newest members, because he promised me that at the end of his talk, he will join the LAA.
Yeah, first few months, but only till December.
5 months.
Yes, 5 freebies.
Act quickly.
Yeah.
But he just retired with the DRP. He was the Deputy Associate Administrator for Programs in the Space Technology Mission Directorate. They have a tricky thing they do up there. They will call you and say, hey, we got a 1-year detail. Will you take it? If they like you, it turns into a multi-year detail. In this case, 6 years, and until he finally decided the DRP was the opportunity he was looking for. Up there, he was responsible for executive leadership of 10 space technology programs with an investment portfolio of over $1 million annually. Billion. Prior.
His child
Prior to his appointment to SDMD, he spent 30 years here at Langley, most recently as the director of the Space Technology and Exploration Directorate, where he led an organization responsible for developing technologies for human spaceflight and robotic exploration. He has also previously served as Langley's chief engineer. He is a recognized expert and consultant on hypersonic flight, planetary entry systems, and bicycle. He is a fellow in the AIAA and has received numerous achievement awards, including NASA's Exceptional Engineering Medal and the Meritorious Presidential Executive Award. So give a nice round of applause for him. And it is a plus. So we are honored today to have Frank Taylor here. Our talk, and I guess I should have had that up there mentioned somewhere, is going to be the 40-year history that went from HL20 to the Dream Chaser, which is expected to have its first launch either late this year or early next year. And we are so fortunate in having Frank here to talk about that. He's been involved in the Dream Chaser program from its inception, actually. He's a graduate in mechanical engineering from Cal Poly San Luis Obispo. In June, he retired as a senior director of technology at Sierra Nevada Corporation. It's interesting, I had to ask him over in the Badge and Pass office. They're located in Colorado. And I said, my mother grew up in Kentucky and they always pronounced it Louisville. How do you guys pronounce it in Colorado? He says it's Louisville. I didn't want to make the mistake of saying Louisville. You got to put all the letters in there for the post. But Frank retired in June of 24 and he started his own company. So he's really not retired, although he says he spends about 40 hours a month, which is a little bit better than what he was doing, but his company is Ultimate Next Transportation, LLC. Sounds like an interesting company to sound. He was, now we get to the HL20 Dream Chaser story. He was one of the 2 folks that came here in 2004 to talk to Langley about the HL20 program and how they might be able to turn that into the Dream Chaser. So he's been working that He started with a budget of $90,000 space grant from California, and it has now grown to more than $2 billion in the program today. He, besides working at Sierra Space, he has more than 40 years of aerospace experience. He worked at Lockheed Martin Skunk Works for a while on the YF-22, the X-33, the JFS, as well as other vehicles. He worked at Scaled Composites on several aircraft, both crewed and RPV, and he worked at ATK on composite and ceramic structures. His engineering capabilities include composite structures, propulsion systems, radomes, RF system installation for aircraft, launch vehicles, missiles, and small satellites. So please give a warm round of applause to Frank Taylor, who came all the way from Tucson, Arizona, where he's out helping with his new grandson, granddaughter, grandson. So, warm. I think they're going to load your slides, and he's going to talk first about the HL20 program, and then he will ask Frank to come up, or Frank's coming up right now. Maybe they're going to tag team.
No. Okay, so I need you guys hope because it's not going to come through. Oh, yeah. Yes, for that.
Okay, while we're waiting for the IT problems, which never seem to go away, good to be back. Last time I was here was about a year and a half ago, February of 24. Been talking on Space Technology Mission Director. I thought at that time, the next time I'd be back here, I'd be sitting in one of those seats. But I promised Kathy and Dave and others I would be the next new sign up, new member of the LAA as soon as I'm done with this talk. So good to be there on that side. So a couple things. I'll just say that the arc of my career actually began and is ending with the HL20. The very first day I showed up at Langley, the vehicle analysis branch, with Al and Wilhite, Chris Cruz took me and introduced me to Bernie Spencer. Bernie was an old-time experimental hypersonics wind tunnel guru. We went over to the model shop and looked at one of the HL20 models that Bernie was getting ready to test. I don't know which of the facilities he was testing in, but that was sort of a model buy off my introduction to wind tunnels and VAV and HL20 at Langley. So that, and here I am at the end of my career, getting this talk. But in about the middle, I actually met Frank and Mike Jeffries. I can't tell who's on, assuming there are people online. I can't tell who's on, but I think someone said he was going to be here. So
he's on.
We may hear from Mike here before the day's there. But it's really good to be back. And thanks to Dell and Doug Morris and Ted Talley, who asked me to do this talk. We started talking about it, I think, back at the beginning of the year, January. At that time, Dream Chaser was supposed to fly now. I think it was May. If I were listening to be perfect, Dream Chaser little phone will have some great data. They can see the perfect cap at the beginning, the concept to the flight, the HL20. Anyhow, it's good to be here. Thanks for letting me come back, help tell this story. So, what I'll do. If I can get the slides to advance. Is that everybody hear me okay?
Yeah.
Yeah.
This is good? Okay. Yeah, this is not.
Let me see here. Yeah. Yep, now we'll do that.
We could just stay on this slide the whole time. I'll be working that. I'll just, so I can tell you that I can't talk about the HL20 without talking a little bit about the lifting bodies. Lifting body program was something we started in 1960, the 60s. Still on the heels of Apollo, Mercury, Apollo, those were the development of those were done. Thank you. And NASA was starting to look at more higher performance re-entry capabilities, controlled maneuver flight from low Earth orbit. hollow and flown. They're more ballistic for very, very small lift and steering ability. But the lifting bodies were actually looking at the ability to steer and control and maneuver during entry, which actually gives you a lot of performance characteristics. You can get a lot of cross range, you get down range, you can get to a lot more places. You don't have to wait for orbit phasing to get home from some station. So there were actually 3 lifting bodies that were flown. The X-24, which is on the left, that was actually an Air Force. The N2F3, which was a series of vehicles that proceeded by the N2F2 and the N2F1. Those were designs that were being promoted out at Dryden, now Armstrong. I think there were some Ames folks involved in that. And then the HL10 was actually the lane entry into the lifting experiments. And these flew for about 10 years, mid-60s up until mid-70s, and basically informed the shuttle program. When they started designing the shuttle, they took advantage of a lot of things that we had learned in the lifting body program. I will say of the 3 lifting bodies, the HL10, the Langley design, was the one that I heard the most. It had the best handling qualities. So there's that. And in fact, if you go to Armstrong today, I just was there 2 weeks ago, 3 weeks ago. That was the last summer I visited in my NASA career. The HL20, I'm sorry, the HL10, first MUC as you drive in the gate. So it's still there and testament for lifting bodies. Okay, so fast forward to about 1983, in the Indian Ocean, the Australian Navy's flying around in a P-3 aircraft, and they see the Soviet trawler fishing out this strange-looking vehicle from the Indian Ocean. At the time, nobody knew what this was, but the Australian Navy thought maybe the U.S. would be interested and might have some interested in knowing what it was. So they sent these pictures to some people in D.C., one of the 3-letter acronym government agencies, who came to Langley and said, "What in the world is this? We'd like to know. And more importantly, we'd like to know what it was capable of." Adele Freeman, who's back there in the back, you can see, and some folks from the vehicle analysis branch spent a little time studying this vehicle and trying to figure out exactly what it was. So I have these charts that I think Dell gave to this. He gave this presentation. I don't know, it was a couple months later. And I see Ann Costa back there, and I'll just have to say, a lot of these charts, Ann was our graphics designer for many years in the LAA. So she created almost every one of these charts that you're going to see. Thank you, Ann. But these are Dell's charts that he briefed to this other government agency on what they thought at the time they called it the Cosmos 1445 vehicle. Apologies for the markings, because at the time they were classified and had secret markings all over them. They've long since been declassified. But they came down and asked Langley to help figure out what this Cosmos 1445 entry vehicle was and what maybe the Soviets were actually planning to do with it. They said he used whatever information. Here's the pictures. There might have been some telemetry data that we could or could not speak about. They used basically just what you saw there, these photographs, and recreated that vehicle, and basically did a systems analysis to understand what that vehicle was really capable of, what it might be used for. There was the team. So it was basically Dell and Bertie Spencer, who I mentioned before, and Bill Woods, Chris Cruz, Mac McConaughey, and Jim Young, and then Dick Powell and Ted Talley. And you'll see their names. I'll talk about some more of what they all did throughout. But this was the original team looking at that configuration. They looked at the pictures and basically actually learned that there was a lot of information to be gleaned just from the pictures themselves. They recreated using what was really CAD system, computer-aided modeling. The outer mold line, I think this was probably past the days of lofting and slide rules, but pretty good computer capabilities. The vehicle analysis branch recreated the vehicle outer mold line. They just by looking at how it was floating in the water, they could tell the displacement and get a rough estimate of the mass of the vehicle. It was hanging on a sling when they pulled it up out of the water, and they figured out where the CG was. They actually took those mold lines and built some wind tunnel models and spent a few months I don't know how long it was, Dell, if it were months or weeks, but they spent some time, 2 months, 2 days. 2 days. I couldn't do that anymore.
The agency wanted information and they were coming to visit. Dave Rollins in the shop, he built the model in about 3 days, I guess it was.
3 days.
It had been tested in the helium tunnel when they came. So we had that piece of data that made tweaked our interest. It trimmed it maximum LOD with no control.
I'm going to show you that slide just a minute.
That was,
Yeah,
we were coming off the shuttle program where we've been wrestling, Dick Powell been wrestling that problem forever, so it got out.
Yeah, I don't know if those online could hear Dell, but it was a pretty quick turn, a couple of days, not weeks or months. Not sure you could do that in today's environment, but it was there. Apparently there were some people that were really interested and wanted answers quickly. So this was just the initial estimates. They looked at what they called a half-scale vehicle, which was the picture that you saw, which was only about 13 feet long. They thought maybe that was a subscale prototype that the Soviets were using to develop a more capable crewed vehicle. That one was obviously not. It was too small for humans inside. But they made some estimates of the entry mass, and the launch mass and landing. And then, as I said, they built some wind tunnel models. They tested first in the old helium tunnel, Block 1 helium tunnel. I also got the models into the NTF pilot tunnel and the unitary sections 1 and 2. Here's the piece of information that Dell shared. This was a really high-performing vehicle design. The Soviets had probably taken what we knew about lifting bodies and maybe even improved upon it. It had a pretty reasonably high L/D, hypersonic L/D, which gives you a lot of cross range and downward capability, maneuvering capability. And probably more importantly, like Dell said, it actually trimmed at an angle of attack. So for the non-aero people, that basically an angle of attack is the vehicle nose points up and down, and it trims at a point where the pitching moment is actually goes to 0. So you can see on this, if you can see the pointer there, it trims at about 30, 35 degrees, which is right up near maximum L/D with very low control surface deflection. So it was a very capable, high performance design, probably better even than the HL10. So I think it was, I don't know when you actually designated the HL20. But to Dell's point, the group that came down that wanted the information, I think Langley reported out, it was an unmanned vehicle. It was too small for crew. It weighed about 2,700 pounds, maximum payload estimated capability of about 300 pounds. It was not a vehicle that was configured to fly below Mach 2. It basically came in, deployed a supersonic parachute, landed in the water, as you saw. So it wasn't designed to land on a runway, or at least that version of it was not. It was stable above Mach 2. They didn't test it much below that. It had really good cross range, 1,100 nautical miles, so you could basically deorbit and steer into a lot of landing sites. And it had a pretty significant plane change capability. So again, lots of high performance from an entry vehicle, higher performance than, certainly the Apollo capsules, and maybe even as high as or higher than the shuttle, given the L/D and trim characters. And they looked at, okay, well, that was maybe a subscale vehicle. What if it were to be scaled up? What could you do with it? And they looked at a scaled up, basically double the size or double the length, about 26 feet. You could probably fit 2 crew in there with a vehicle weight of about 9,300 pounds. Had a little higher cross range with maximum propellant load. You could do some pretty significant things, including a payload of up to about 3,000 pounds. So, Dell, I don't know what happened. We reported this back, and they said thank you very much, and that was sort of the end of it, right?
We got interested in it, and Langley took it on at that point.
Well, that's the next part of the story. So this is actually information. This is the actual bore for, as that vehicle was known in the Soviet Union at the time. was part of this program called Spiral, which was a Soviet program to look at a multi-stage space transportation system. Used the hypersonic airborne first stage and expendable second stage rocket with what was in the bore forward. See on the front end here. So they studied that for probably a decade, in the 60s and 70s, while we were doing similar things here. But then we started developing the shuttle, and they started developing the RAM, which was their version of our shuttle. Turns out the bore forward, that vehicle they were pulling out of the water, was basically a subscale unmanned test vehicle to test thermal protection system and essentially aerothermodynamics for their bore forward vehicles. It flew 4 times. And like I said, the Australians got pictures of it. There's some really interesting video that came to light. It actually was shot from the boat on the Soviet seamen, I guess. Took pictures or video of that orbiting Australian P3. So you've seen it from both sides now. There's a lot more information that's come out about Spiral and the Bore 4 program. But that's what they were doing. Nothing at the time was nefarious. Seems nefarious now. However, Langley did just what Dell said. We reported out to the group that was interested, and then continued to work what became the HL20 for about a decade after that. Around the same time, mid-80s, the Space Station Freedom design was completing, and NASA started looking at, well, what would we use to basically retrieve crew from the space station? Either shuttle wouldn't be available or shuttle would be retired at some point. So they looked at this design, what was now called the HL20, as a crew return and a crew rescue vehicle. There was also some work on what we call personnel launch systems, so basically a follow-on capability to the space shuttle, which could launch the crew into orbit on essentially an HL20-like vehicle on top of a booster, expendable booster rockets. In 1989, Langley basically got Rockwell under contracts to look at an actual sort of preliminary design from an industry perspective, how they would build and operate the HL20. And then shortly thereafter, Skunkworks. They also contracted with Skunkworks. So they had 2 major industry design shops looking at how to basically take this vehicle and turn it into an operational capability. The mid-90s was something called Access to Space. So that's where the X-33 program started. HL20, was actually considered as one of the options for personnel launch and access to space. And then from 92 to about 2000, where things just started winding down, there were a lot of studies, a lot of reports to headquarters about ways you could utilize the HL20 and get this design went into this. Spent a lot of time and effort on it. And I'll tell you a little bit about that. Okay, go ahead, Bill.
Really what transpired there in the Skunkworks study, we had a program, pretty expensive program, take the first flight. It was $3.5 billion, the estimate, and that was a study they did. And when we surfaced that to Dan Gold, and he said, do it fast, better, and cheaper for $1 billion. And Langley backed away from it. It was a disaster to try to do that.
Yeah, I don't know. People online were talking, what Dell was sharing was the estimate $3.5 billion to get to first flights based on the Skunkworks study. That was in the era of Dan Golden, where he wanted everything done better, faster, and cheaper.
Yeah.
Matches a lot of people probably around that time. Langley wouldn't, if you said that you would keep the Langley. Let's see, what else? There were multiple mission scenarios. HL20 versions looked at the sizes of 4 crew up to 10, station rotation, lots of launch opportunities, getting people in space. There was a lot of additional wind tunnel testing that went on. I'll share some of that here in a minute. Bruce Jackson put together a whole GN&C flight control system. I think Frank may more about it, covers that and something Green Chaser. It was briefed to headquarters many times. There were two administrators, both Dick Truly and Dan Golden. So for about a decade, it was a sort of a front runner in what we would do with post shuttle. Unfortunately, we never got there because, let's see, basically the station design, because was Space Station Freedom, became the International Space Station. Needed something for the Russians to do beyond just build components for that. The Russians have the Soyuz capsule, which we actually then, we in the United States, decided we would utilize and rely on in post-shuttle environments and to provide that crew return and crew rescue capability. So the Soyuz served that function for many years. So in that time, though, there was a lot of additional work. Talking about the aerodynamics work, those three initial studies, the Mach 20, NTF, and unitary. Bernie Spencer, who I mentioned, my first day on the job, that's Bernie up there. In fact, that model, if he's sitting by, touching, the model I saw on my first day on the job, that model is actually sitting over in building 1219 in Old Headquarters. I took this picture 2 weeks ago on my last day. I walked past it every day. I might make it my mission to get here. Maybe after beaches. Anyhow, there's a list of a whole bunch of additional wind tunnel tests that went on, the aerothermodynamics branch and the experimental hypersonics branch, which is 81 in the 90s. They spent a lot of time testing this vehicle, and a whole lot of CFD was sort of in its infancy. These hypersonic reentry vehicles, so there's a lot of work on there. Dick Powell and Chris Snapple, both Dick's online. Chris was out west last I heard. He retired some years ago, but he's still involved in the vehicle analysis branch. They spent years looking at how to wring every bit of performance out of this vehicle. They did a lot of trajectory optimization work. Chris led a lot of the abort studies, looking at how you could use this vehicle, how this vehicle could be able to abort if there were a problem during launch or re-entries. There was a whole lot of work. Kay Worcester and Vince Zodi, Kay was in the vehicle analysis aerothermodynamics branch, did a complete aerothermodynamic characterization, size TPS, pretty robust TPS design. A lot of structural analysis, your Bob's also from vehicle analysis branch led the structures research in this vehicle for many years. So it was a pretty extensive, at least a phase A preliminary design concept by the time it was sort of laid to rest. And I'll say that because it wasn't laid to rest at least temporarily before friends Doug Morris and Nancy White spent a lot of time in operations support. Basically, the shuttle, I think everybody knows, was envisioned as a rapid turnaround. We'll fly it a couple times a month on 20 missions a year, never close to that. Doug and Nancy and the group that they worked with spent a lot of time understanding where the problems were, where the pinch points were with shuttle and what caused it to be such a challenge from a maintenance and reliability, and basically built those lessons into the HL20. And with Lockheed and Skunkworks, I think designed that into the system, make it much more operable, maintainable, and reliable. Get that right, Doug?
Yes. Simple answer, yes.
Let's see, Ted Talley, he's online. He was a big part of this along with Howard Stone. They worked a lot on the subsystems and avionics. Worked with the contractors, both on the what we call government reference design, the Langley design, and then the Lockheed and Rockwell, their designs. Charlie Cochran Sr. Actually worked with North Carolina State University. They built for us a full-scale mock-up of the HL20, which still exists today. I think it's still out in Colorado.
The wings of the Rockets, yes.
Okay. But that vehicle actually came here to Langley, was here for 5 or 6 years. We got a lot of mileage out of it. And this was more than just a showpiece model. It was actually full structural vehicle that we could do through human factor studies, which Ellie Wilshire and Lisa Simonson led. Oh, hi, Karen. I didn't recognize you. This was another one of the first things I remember in my career. Early 90s, I think Kelly and her team with this vehicle, it was set up over in a hangar, and they did a lot of the human factors, ingress, egress. We all got to dress up like astronauts, climb in and around, get in and get out as fast as you can. She had a stopwatch timer. There's some great videos. Unfortunately, they didn't translate very well. I'll show a couple of those, but I will say this: some of you probably know Clayton Turner, who's the former center director here at Langley, and now my former boss, technology district director. Clayton's had a pretty remarkable career, but he says the thing that his mother is most proud of is his picture in his astronaut suit. Let's see, Bruce Jackson. I think I mentioned Bruce. He's out in Arizona. He spent probably more time. A lot of people spent a lot of time. But Bruce lived and breathed this most of his career. He built a full flight control system using the aircraft databases and all the information. Built the full-up motion-based simulation, which a lot of people flew. There's some of the names. Karabakh at the time was just a lowly astronaut. Became the center director of KSC, some headquarters as an associate administrator. Bill Dana. How many of you remember the $6 million man? Opening credits, the $6 million. That was Bill Dana crashing the M2F2, which became the sort of seminal moment for lifting bodies, or at least the ones that you see on regular television. He actually was here. He survived. Mike Full, who else? Steve Ishmael, who was a pilot out of Dryden, we got to know pretty well. Dick Fruely, and then John Young. So they all flew the simulator and had really good things to say about it. Handling qualities, the performance. It was a vehicle that was a lot of fun to fly. I think due in large part to a lot of work that was done here at Langley. Just a quick comparison. Here's again the LOVD leftover drag, and you can see that the HL20 at Mach 20 is that top curve. It was the highest performing, highest LOVD, highest performance of all the lifting bodies. X38 was essentially designed. It was based on the X24 that JSC was working on, and then HL20, HL10. You can see down at the bottom. So a lot of work and a lot of improvements on the HL10 and the HL20. And the one other thing I'll say about the simulation and all the pilots that flew it, they have this what's called the Cooper-Harper scale, pilot ratings, how the airplane, or in this case, the vehicle flies. Lower numbers are better. So in this case, the HL20 had a Cooper-Harper rating of somewhere between 1 and 3, which was essentially good to excellent. You can see all the other lifting bodies, which actually aren't other than X38, are showing where those were at much higher, lower performance, harder to fly, took a lot more work to actually fly. Okay, so that gets us up to early 2000s, and the interest was sort of waning in the HL20 because the International Space Station was now going to rely on the Soyuz capsule. And along comes our friends from, at the time, a company called SpaceNet. Frank Taylor, that's where I met Frank. He shows up in Langley and discovers the HL20. So I'm going to turn it over to Frank and let him tell you the next 20 years and how we got to our day. And we'll save some time at the end for questions. Fair enough? Okay.
Thanks, Walt. Yeah. So, just like Walt was saying, is obviously Langley had a long history of developing the HL20, and I can say that we took advantage of all that work you guys have done over those 20 years, almost 20 years of development of the HL20. Just a little side note, and Walt was mentioning about the bore 4 when it was fished out, that was taken by a picture from a Australian P3. Actually, that year in 1984, I was working at Lockheed on the Australian P3 modification program for them at that time. So there's a little 6 degrees of separation here over my career of 40 years and the HL20. So first of all, why is Space Dev interested in doing a space plan? Well, you got to look back to the history of Space Dev. Space Dev back in 2003 and 2004 had essentially done 2 major accomplishments. One was a microsatellite called ChipSat for the University of Berkeley to do some measurements in IMCs. This was one of the first early small sats that were built and launched. That vehicle actually was still operating, but not transmitting anymore. But that was one of the early accomplishments that Space Dev had done. Also, they were doing hybrid propulsion. If you remember Spaceship One, we built the Spaceship One hybrid rocket motor. It was about a 15,000-pound thrust. It's an amazing story about that, the 15,000-pound thrust motor. It started as a 5-pound motor 18 months earlier before that flight going to space. And so in 18 months, 15 test flights on the ground, that team you see right there sitting there, it's about 25 people sitting right there. The Space Dev team in 2004 took that little 5-pound motor, got it ready for a manned spacecraft on Spaceship One to go up twice, as you can see on the dates, and with the final one being in October 2024. I joined the company in 2004 in September. I was the 32nd employee at the time. And so if you remember some of the back history, there's 2 people involved. First of all, there's Scale Composites, Burt Rattan. I worked at Scale Composites for a while too. So I knew Burt very well. And then I started this new company here in September of 2004 called Space Dev that submitted a proposal to try to look at taking our hybrid motors and putting it in an X-34. Now, the reason for that is because of the 2 people who led those 2 different companies. One was Jim Benson, and you can see the kind of history of Space Dev and Starsis and following on. But then there was also Burt Rattan. Both of them had very large egos. I'll let you decide who you think has a better technical prowess than the other. But essentially, that was the reason why we no longer were willing to work with Scale after this accomplishment, was because of the bad blood between the 2 leaders. At the working level, we worked great. In fact, myself and several other people had worked on both sides, and we had a great working relationship with Scale. But because of the 2 leaders, Jim Benson and Burt Rattan, couldn't stand each other, especially in October of 2004, they couldn't even be in the same room together because they hated each other that much. So what it really came down to is we had to come up with something to try to move forward with these 15,000-pound motors that we came up with. So what we first started doing was, like I said, the first thing we did was submit a proposal back in September of 2004 for a space grant, and we got granted that in December of 2004, right between Christmas and New Year's, to get do a study on putting our hybrid motors into now the defunct X-34 that was stationed up at Edwards and just rotting away in an old hangar up there. You're going to see some commonalities here. There's a lot of wet old hangars that this program has gone through. I'll go into more of that in a little bit more. But essentially, there are some of the key personnel that we first started this study with was Dan Rasky and Phil Smith. Phil Smith was actually an employee of Space Dev back in the early days, and then gone off to do the Space Grant Foundation, and that's how we got our money. So the good old boy network still does work sometimes. But again, it was only $90K. Dave Kinney was also an analysis engineer from Aerothermal up at Langley. And he's an important person when I get to the next slide. But you can see what we were looking at, essentially taking that old airframe. There's 2 airframes. And if you remember the X-34, there was a little engine called the Fast Track engine. Key key remembrance here, lesson learned, pick your names for programs wisely. It wasn't that fast track. Obviously, it never got there. They had the airframe out there at Edwards. They actually flew and it never actually did a drop test, but it did captive carry testing with the those vehicles, with the one vehicle that is painted in color. The other one was sitting there waiting for the engine to be installed and go forward. But as we all know, the X33 and X34 got canceled about that, around the same time. I was on the X33 at the time, just to give you a little preview. And then all of a sudden, there was, like I said, this started off as an orbital vehicle. Then all of a sudden, we started hearing rumors about this thing called COTS. Well, COTS was an effort out of Johnson to try to do commercial orbital transportation system. And essentially, it is the start of our Dragon that is now flying up and down and going. And also the Orbital Sciences / Northrop Grumman now vehicle going up and supporting cargo support. It started back in essentially how it all started was, guess what? Elon Musk protested that Kistler had gotten an award to actually build a launch vehicle, a reusable launch vehicle. And due to that protest and the also agreements or comments from the GOA, that program was canceled and then was forced to reorganize itself into what then became COTS. And COTS was essentially being rumored about in February of 2005. So halfway through this 90K study, big, huge amount of money, and 32 people in the whole company, we essentially pivoted. And that pivot was, hey, based upon what we had gone through the vehicle and said, yeah, the X-34 could go up to orbit, but it wasn't coming back into orbit. So we could get it there, but that was going to be tough. And then this one engineer, Dave Kenny from NASA, said, hey, you ever heard of the HL20? We all looked at each other with, don't even know what you're talking about. Well, that was the beginning of a long journey that has now been going on for more than 20 years for space dev to actually go and look at that. Some of the key people there on the Johnson side was obviously Alan Thorne and Alan. They were the two leads, and of that COTS effort. That COTS office was only just the number of people you can see up there. But Valen and also Laura Cigar was probably the two key people on the side of NASA that really got interested in our using HL20 with a hybrid motor inside of it to be for an abort motor to actually be able to work. And you can see the evolution from the previous slide to this slide here, showing the now the orbital configuration of a HL20 on top of 3 large hybrid rocket motors. We did a final presentation at Ames back in that was July of 2005. And the biggest thing that happened during that time, as a program manager of that program, was that we went from a 90K study to a 110K study. So about 25% increase in funding. So that was the beginning of what we started going down through and looking at the HL20. Now, HL20 at that time was strictly right off what you guys had pretty much done. Not at the very end, but nearly the end, the configuration that you had. You essentially had slab fins, had a round radius on the slab fins, but that was the configuration that we pretty much started with and we did for the end of that study. Then came trying to understand the HL20 a little bit of it. Walt showed you some of the earlier slides of building the mock-up. That mock-up was what Jim and I came out to on the second part of the study and came out and saw the HL20 in April of 2005. And so that was our first introduction. I will say there's some white stuff on there and you can figure out which animal deposited that inside the hangar. But there's some very, that was the start of, I call the archaeological dig. And then we have the John Martin and Glenn Bobsey. I think Glenn's in here somewhere. There he is. And we used to call him the John Glenn team. But that was on our side of the thing. I don't know if you guys ever knew that. but we just called you guys the John Glenn team. And they were the two archaeological diggers to get most of the information and the wind tunnel model out of old hangars buried in old bunkers around here, along with Bruce Jackson. Bruce Jackson, the one who got us to actually go into the vertical simulator, the shuttle vertical simulator, and actually get to fly the HL20 simulator. And so that was one of the neat things happening in the early days during that study that we got going. And all I can say is it was based upon all the work that here at Langley done for almost 20 years on HL20 that we were just pretty much stepping on their shoulders and moving forward with. And so I've got a list of people here that are also involved, more than just John, Glenn, and Bruce, but there's more than people I could ever put on this slide. But this is just a sampling of some of the people that we've dealt with over the years on the HL20 and still dealing with going forward here for our first flight that'll be coming up. And so that was essentially, getting through that study. And then obviously January of 2006, the actual proposal RFP was released for COTS. And so at the time, there was like 21 people, 21 companies that were actually pursuing that at the time. And that came out, and then we submitted our proposal in March of that year, 2026. And then there was a down select to essentially 6 people in April, or actually in May of that year. And then during the summer months, we had what was called the findings. And just as a little anecdote, along with getting ready for all that, we transported the HL20 from Langley out to Colorado. Now, let me tell you, trying to get a 15-foot wide vehicle through multiple states all the way out here was the challenge. And instead of being 15 feet wide, we made it 12 feet wide, which is a big difference in wide loads and regulations, and got it out to Colorado. And this is how we got it out there. And so now, like we talked about earlier, you can see the HL20 mock-up. It is now has some markings as a dream chaser, but it is still exists today at the Wings Over the Rockies Museum in Denver. So if you're ever in the Denver area, it's where the old Denver airport used to be. It's in that area, and I highly encourage you to go see it. They've done a great job of setting it up, and they actually have days that you can actually go inside the cockpit. And like I mentioned about doing egress and ingress training on it, that was done also with that model. And they actually allow you to go at the museum, actually go inside and see it. So here's the motley crew that actually proposed that vehicle and did all the findings. Like I said, at this point in time, it's down to 3 companies. So it's SpaceX, Kistler, and ourselves, Space Dev. And we were pretty much in a 2-way tie with Kistler. SpaceX was pretty much obvious winner at that point in time during that down select. And we went through what we called the 1 through 5 findings. It was a series of findings. And we believe NASA, after we gave them a book of responses to pages, they said after that, they limited us to 5 pages per question. The book was 3 times thicker than the original proposal. So, so I think we maybe caused that. But yeah, that was just one of the anecdotes there. We went out to the headquarters back in August of 2006 and did the final presentation. And the actually technical committee had sided with us, but the lead of the proposal evaluation team decided to go with Kistler. Well, if you knew Kistler's history, they had gone bankrupt 3 times before this. This is what I call our first Phoenix moment. Is we were right there, tied for second, and did make it across the finish line. That was in September of 2006. So I'll never forget that day. But we were kind of devastated. But as you'll get to understand as we go forward, we decided to keep moving forward with the unfunded Space Act agreement we set up with Johnson at the time, and to keep moving forward. So as one of the key things that we did was to actually make the OML vehicle. And as you saw in the earlier picture with John Martin next to that HL20 model, we took that model, and I'll go into more detail a little bit later, and made it into an OML, along with obviously coming up with flight test arrangement, our hybrid motor for the board motor was to do a design review and then do a firing. And so you can see we accomplished all those under self-funding. Obviously, unfunded space activity means everybody was Dutch, and we moved forward. And so they go in a little bit more detail about the HL20 and what we did with it, and some of the modifications we did at that point in time. This is kind of the first round of physical changes we took from the actual HL20 loft that was digitized. As you can see, we just took that model, digitized it, put it into our CAD system. Two people who were biggest responsibility was Roger Hayes and Jeff Heckerson. Jeff Heckerson was an employee of Space Dev. Roger Hayes is a person I know who was a contractor at the time, but he and I worked on YF-22. He was the lead lossman of the YF-22. I also worked on the YF-22. And so that was how we got to a configuration that was now digitized and in 3D at that point in time. We did some changes. There was a big change to what we call the cat eye, the two major lenses that the Soviets had done on their Bore 4 at the time. And just a little back history, I don't know if Walt mentioned this, the Bore 4 was supposed to be a single pilot space fighter. That was the original design and why they were designing that vehicle. But then it became the test article for the TPS for the Bore 4. So, excuse me, the Buran. For the Braun. And so that was a kind of interesting thing back then. Also, we incorporated the wing foils. The very last thing that Bruce Jackson had incorporated into the landing model was a better LVD at landing. And so instead of having the slab fins with just a big blunt nose on it, and we incorporated the airfoil that was essentially incorporated into that model at the time. We did find out, and we had suspicious when we saw it, was that airfoil hadn't gone through aerothermal analysis yet. And sure enough, that was the case. And later on, we maybe had to change that. But that essentially got it to 4.1. That's how the big improvement in landing qualities was, because of that airfoil shape. And then, like I said, the windshield and then the tip fin changes. How it tapered off there. So those are the big changes we incorporated back there, self-funded back in 2007. And then came COTS 2. We all know Kistler repeated its history. As they say, history repeats itself. Went bankrupt again for the fourth and final time. There's a bit of a history there, but I'll get into some more of that a little bit later. But essentially, they got terminated officially in October. Later that month, they turned around and released COTS 2. They had a little pre-planning, I think, going on there at the point in time. So the RFP for COTS 2 came out, and multiple people bid at that time, but one person was selected. That was essentially Orbital Science. We had made a major change. As you saw, our previous configuration had multiple hybrid rocket motors being our launch vehicle on COTS 1. COTS 2, we went out and said, hey, if you're going to have, instead of having just one configuration, let's have 3 different orbital launch configurations. So we teamed up with LAA and got an MOU with LAA at that time, and then also looked at incorporating onto the essentially the Ares booster at that time. And so the solid rocket motor booster. And so that was our 3 launch configuration for COTS 2. That time we didn't get anywhere. In fact, we didn't even make it to the final down select. We were eliminated with multiple other ones and only went to orbital. At the time, if you remember, there's a little back history there, a little story, that on COTS 1, orbital joined Kistler at the very end of the findings time. So they weren't even in the original proposal. During the findings time, when they were doing the due diligence, they joined the team. 1 month after the award was awarded to Kistler, Orbital quit the team. And guess who got the next COTS, number 2? Oh boy, network still works very well. Left them money. So that was sort of what we call Phoenix moment number 2. Well, Because of that Phoenix moment number 2, luckily enough, we had a CEO, Mark Sorangelo, who still kept believing in this. And bless his heart, he essentially made it possible for myself and several others in the company to keep moving forward. So what the moving forward was being able to get a MOU and a signed MOU with ULA. ULA had just become a company as a combination of both Boeing and Lockheed at that time. In January of 2007, we were the first MOU through a new company. Lesson learned: don't be the first guy. Took a while, but that was several of the people there that really helped us quite a bit on there. Like I said, Bernard Cutter, he's since now passed away. Mike Hogan and Jeff Patterson, both were key people on the ULA side that really made this integration of our Dream Chaser onto a fully launched vehicle capable of taking crew. And so that you might recognize this guy right here. He's kind of famous, maybe the second guy on the moon. But Buzz was very fascinated with it. He was one of the guys who pretty much told me he liked the idea. And I had a lot of people in my own company going, Frank, all you do is Dream Chaser, Dream Chaser, Dream Chaser. You've got two times you were told no, and NASA just wants capsules. Why keep pushing? Well, thank goodness that there's other people both on the NASA side, especially here at Langley. I didn't ever get that question from Langley, never. Johnson, yes. We all know about Johnson. But Buzz was really the one who really kept saying, hey, keep going. And he's the one who really kind of helped Mark keep saying, hey, let's put some money behind this. And so internal funding, we kept moving forward. And during that time, we had gone from doing Spaceship 1 motor of about 15, 16K to now a 70K motor for Spaceship 2. If you understand the history of Spaceship 1 to Spaceship 2, Scale tried to do their own motor and had an accident with it and killed 3 employees. And because of that, they actually came back. At that point in time, Jim had gone off and did his own company and then passed away just a couple of years later at the age in 2008. And so, but that coming back to Scale, or excuse me, Space Dev, to actually do the motors for Spaceship 2 was a major changing point. Like I said, the working level, we always were a great working relationship. But when it came to the top level, these two didn't have to work together anymore at that point in time, because Jim went off and formed his own company called the Benson Space Company. I will always lesson learn. Look at what the abbreviation says. The BS company is probably not a great abbreviation. So, lesson learned. But like I said, we funded our own interior development on that vehicle to keep going forward and actually look at things. And like I said, there was a lot of objectives that we were trying to meet at that point in time to get that ready for what we knew was going to be CC Dev. CC Dev was being rumored to happen. There's a little funny story there. We were on a 9:80 schedule, so Thursday afternoon was last Thursday for us for the working week. And we had a IRAD meeting about, hey, that was just late 2009, going, hey, this is just not happening. We just can't keep spending money waiting for NASA to kind of release CC Dev. Why won't we just shut the thing down? So Thursday night, we made a decision to shut the thing down. Guess what? Friday morning, out came the RFP. So that August 10th on 2009, the RFP came out and we started going after it. At that point in time, we got a little bit smarter about, hey, you got to team with some people in this industry to make it a viable company. Again, we were just a small little company called Space Dev that had then been acquired. You remember earlier on the slide presentation, I mentioned the history of Space Dev becoming part of Sierra Nevada and then becoming part of Sierra Space. And at that point in time, we were part of Sierra Nevada at that point in time. We were a combination of 3 different space companies, and we're moving forward. You can see the multitude of people who went after that proposal. There was a lot in there. And this is probably one of the high points in my career, one of many, but being the top winner and beating Boeing for a difference of, $2 million, from $18 million to $20 million, we granted our CCDF1 award in that year. And it actually really didn't start until 2010 is when the really effort started. But that's the proposal team. Again, that was when we were Sierra Nevada at that point in time. And so at the point in time, that team that started that back in 2010 was a total of 7 full-time working employees. So just give you a sense of size at that point in time. Well, we had to grow a little bit, and going from 7 people that could meet in a conference area. Essentially, we had cubicles that were surrounding an area, and all we had to do is turn our seats around and had a table in the middle, and that's how we had meetings. And that team grew from essentially just getting to 7 people to 200 people, all the way through CCDF1 and CCDF2, and all the way through CCICAP and CPC. These were some tough moments during that time period. Again, here comes the third moment of what we call the Phoenix moment. The third time. This is when we had the drop test of the vehicle. You can see there's something missing here on the left side of the gear. So there was only one main gear. The right side came down, the left side didn't go. The nose gear came down. It didn't do a great rollout on the landing. It truly tumbled down the runway. And so that was sort of Phoenix moment number 3. And then soon after that, in 2014, we were eliminated from the 3-way competition of CCDF 1, 2, and CCICAP between ourselves, Boeing, and SpaceX. And Boeing was chosen over us. SpaceX was obviously the perceived front runner. And at that time, we were 200 people full-time working on the program. Now, that was probably one of the roughest days I can remember in my career, one of many. But losing half that team in one day was tough. And to their detriment, there are some people who actually got laid off that day and came back and started when we actually were able to resurrect ourselves. And so here's the second resurrection. We had to pretty much pivot. We had to pretty much had a major, it was all about crew. We did nothing but crew. And the upper management in our company had pretty much decided we were just going to repackage and just put, instead of people in there, we're going to put cargo only. Well, some of us engineers had looked at the RFP and said, hey, we got to do better than that. Just taking 3,000 pounds up and down is not going to be a winning solution. And so one of the things we had to do was look at, hey, how do we make Dream Chaser truly a better vehicle? Well, it's just kind of interesting. We added this thing called the cargo module on the back end. Well, that cargo module was part of our COTS 1 proposal effort, actually. And because we had to do both cargo and crew. And during that time, we had looked at putting a cargo module on there to increase our capability going uphill. And so, and being able to burn up trash on the downhill side. And so that was one of the major changes. This is kind of the next big changes that we did. Obviously, we added the cargo module. We added solar arrays because we had a longer time and duration. Instead of just going straight up and coming straight down like the shuttle, we had to be able to stand and be able to stay for long periods of time outside of that. And then we also removed the windshield. There's obviously the obvious reasons to remove the windshield: cost, schedule, complexity, weight. But the real reason was because the mice were going to get scared on the way down outside there. And so one of the biggest things was bringing back mice back from orbit. And so, you know, that's the real reason we eliminated the windshield. I'm still sticking with that reason. The biggest change we did was folded fins. That was because we were going to go inside a fairing, because obviously being unfaired and being outside was a very limited list of launch vehicles. By putting itself into a 5-meter fairing, we're now flexible to launch on different vehicles. We ended up going with the first the Atlas V, and then when Vulcan came along, they were planning on Vulcan, so that's the vehicle that we are currently slated to launch on going forward. The other big thing was the TPS tiles on the upper surface. Before it was all blankets because you only needed that for re-entry, but we had to change that to tiles was because of MOD hits while you're at station. When you're at station, you're kind of the front sword of being up there mounted to the station, and you take the direct hits coming in. And because of that, we had to go with essentially tile instead of that, even though from an aerodynamic standpoint or aerothermal standpoint, you didn't. Obviously, we took out the escape motors. Didn't need to worry about that. RCS changed to now a nitrous, N2O, and ethane, and then eventually to peroxide RP1. And so that was a major change at that time. I don't think they're still liking the peroxide change. It is very much of a challenge. Peroxide might sound green, however, it can kill you. Just a small amount of 70 parts per million can actually kill you. It'll burn your lungs from the inside out. So it's like, mustard gas. And so that is one of the things that we've learned over the years, that peroxide sounds green, like, oh yeah, what you deal with at home is 3%. This is 90%, and a little bit of difference of handling. Obviously, a launch vehicle, we want to A. And then this here is, again, we did a lot of testing out here and also other else places to actually fill out some of that. And Mike Jeffries, who's online, and along with Steve Chan, did a huge amount of testing to actually get the aero database of that vehicle now with things. And one of the big things that we had to change was also the actual airfoil shape. We had to go back in and change that to a much more acceptable airfoil shape for re-entry. And so that was another change that we did to the vehicle. Just a little lessons learned over the years. If I had to start this whole thing over again, hindsight being 2020, obviously, but the bore 4 had variable dihedral. Everybody thought the only reason that thing varied was to be folded up into a fairing. No, actually we learned based upon later data that obviously you guys didn't have when you first looked at this thing with just pictures coming off of a P3, was exactly they controlled the vehicle by variable dihedral on the reentry. And guess what SpaceX is doing on Starship? Starship. It's being variable dihedrals on their fins. That's how they control that vehicle. The Russians did the same thing on the Bore 4. That's how they got away with slab fins at landing, is they could actually decrease them down to maybe 15 or 5 degrees, almost flat when they landed. And so that's what the Russians had done way back in the 80s. And so just a lessons learned, we might have should have gone down that path. Because obviously the angle and the dihedral angle that thing's at is a compromise between re-entry and landing. And obviously at landing, you like to have them way down. Re-entry, you like to have them way up. You actually fold it in so they don't even see the heat coming in. And so that was one of the things that if I had to start this whole thing over, might consider it. One of the other fun things, one of the high points, I call it a Rocky Mountain high point, was actually having a successful landing. We took the broken Humpty Dumpty that tumbled down the runway, rebuilt that vehicle. We called it the ETA, Engineering Test Article, and actually landed again in 2017, successfully this time with all the landing gears coming down. And then in 2018 at the National Space Symposium, we were able to actually have that out there. And Mike Pence, the VP, was able to go with our owners and actually tour that vehicle. And so that was another high point of making it get there. But like I said, we had gone through 4 different, essentially, I call them Phoenix points. Now you know why we call it tenacity. That name didn't come just by someone's great idea. It came through hard work and going through. Just like you guys at Lang had gone through several ups and downs on the HL20, which is probably at least 3 or 2, at least 2, I know, 3 possibly. And R4, well, they say cats have 9 lives. We got a couple left maybe. And so, but right now, probably the launch date for this vehicle is going to be essentially coming up the first quarter of next year on a ULA Vulcan. Vulcan is supposed to fly either today or tomorrow with the heavy lift version, which we need, which is the 4 solid rocket motors to get us up there. And so that is what we're looking forward to is there. We will be, like I said, taking off from the Cape but we'll be landing at essentially Vandenberg Air Force Base, just like the X-37. X-37, its first couple of flights all came into Vandenberg and then eventually moved to the Cape. And so that's probably the same way Dream Chaser will go. First flights going into the Vandenberg and then coming here. One of the major reasons is if on the trajectory coming into Langley, obviously you got a north and a south entrance on the runways there down at the Cape, the shuttle landing facility. If you're coming into a south or north heading, our trajectory at Mach 6 goes right over Orlando Airport. So if you ever wanted to put a hypersonic weapon into Orlando Airport, our trajectory was as close as you can get anything. And so that's kind of the reason why we're getting forced to actually go our first flight into Vandenberg. So that was always our backup. It was always there for a backup, knowing that that was probably going to happen. After a letter from the FAA saying, we highly encourage you to consider, like a 4x4 hitting you on the back of the head. But essentially, that's what got us to do that. And again, like I said, we did a lot of wind tunnel testing all the way up to 2019 to do the aero database. It is now fully been characterized. And again, thank you to all the work that's been done here at Langley on the HL20 and also Dream Chaser. It still went on for, it's gone now. This vehicle is now gone for 4 years from concept to hopefully now getting the fly again. And so nothing happens quick. So tenacity is his name, and hopefully we'll be flying here this next year. Thank you.
We just have just 2 or 3 questions. Sorry, yeah. Do you have any here?
People are online.
No questions? Any questions for anybody? Yes, John.
With all the Russians, Soviets, was there ever any connections with any of the engineers that actually worked on it on the Russian side?
I think after the fact.
After the fact, right? Yes. Mark Tarangelo went back there to Russia. Actually talked to some of the old people who did the bore for. Actually, one of our engineers who's still on the program actually went back there and found one of the bore for. They had 4 different flight tests. Actually found one of the flight test articles in a museum, which is at the end of a church, in a tent off the building. And if you know Russia, how bad the winters are, it's actually in a tent inside of there. And they got a little stool you can sit on inside of this thing because it's been rusted away over the years, but it's still sitting there in a Russian museum.
Okay.
One of the Bore 4 actually flight tables.
John, to your point, I think there's a lot of data exchange that happens, so we know a lot more about it now than we did.
Yeah.
Yeah, like I said, finding out that the dihedral was variable all the way down